Hi, so this video is going to try to help you understand rate of change. And we're going to focus on linear rate of change by graph. And it assumes that you already learned y equals mx plus b, and you just want an emphasis on understanding rate of change. So rate of change is a number, and you can see it as a number in a word problem, or you can see it as a number in an equation, or you can see it as a number in a set of points, like an XY table of points, or you can see it in a graph visually. So we're going to focus on understanding it visually in a graph, but all those other things are going to come into play as well. So let's take a look at this particular problem, and then we're going to talk about graphing it. Mr. Snickerdoodle is being accused of murder. He claims that he was taking a walk at the time of the crime. There is a video of him standing 1 meter in front of his own house at exactly 8 a.m. The detective can tell this is true because the town clock is behind Mr. Snickerdoodle in the video and starts chiming exactly when the suspect starts walking. The area from Mr. Snickerdoodle's house to the crime scene has many people, and no one noticed him in particular. The murder was committed 8 kilometers from his house at 9 a.m. The detective estimates that Mr. Snickerdoodle can walk at the rate of about 2.5 meters per second without anyone noticing him walking particularly quickly. This means that the distance that Mr. Snickerdoodle can go is y equals 2.5x plus 1, where y represents how far he got in meters and x represents the number of seconds that have passed. Okay, so that means that if I want to know how far Mr. Snickerdoodle went, I can just plug in how many seconds have passed, plug that in for x, and then I can find out how far he's gone at that point in time if I solve for y. Notice that I also see the word rate here. That is indeed your rate of change. So rate of about 2.5 meters per second. A rate is how fast something changes, either how fast it changes by increasing or how fast it changes by decreasing. So here it's 2.5 meters. How fast is it increasing? Because it's becoming more and more. It's increasing by 2.5 meters per second. And there always has to be a unit. So you're saying in terms of what other unit is it increasing that fast? Okay, so rate of change always has to have 2 units that it's comparing. So it often uses the word per in between the 2 units. So you can tell that it's a rate of change if you see that word. All right, so let's take a look at one question. Graph A is graph the equation to see a visual of how far he, Mr. Snickerdoodle, can get. So to emphasize what we're doing, we are graphing the equation from the problem, which was y equals 2.5x plus 1. So I'm going to write that down. So this is the equation that we're dealing with. I'm going to do that in that color so we can emphasize it. Step 1, make an XY table and select a lot of small values for x. So I'm going to go ahead and you can draw an XY table. I'm going to draw one here. And then I'm going to also show work on this side. So show work on how to get the y value. All right, so first it said select a lot of small values for x. So I'm going to just choose a lot of small numbers. So 0 is small and easy to plug in, 1, 2, and 3. If you're thinking about how many are the minimum number of x's you can put in this table, you need a minimum of 2. However, if you want to graph accurately, it's a good idea to have 3 or 4 points. So I'm going to use 4 points here. All right, step 2, plug in each x value that you chose into the equation and solve for y. All right, so I'm